So, for our last lesson of the year, they're going to talk about using trig models to model things in real life. Typically, trig functions, specifically sine and cosine, are good math tools for modeling periodic behavior or events that repeat at regular intervals over time. Modeling trig functions uses sine and cosine functions to represent periodic and real-world data like waves, temperature, or pendulums. Most periodic functions will have a maximum value, the highest, or the minimum value, the lowest. There's typically two kind of models they're going to show you. So again, the big thing that they might change is if it's going to be a sine function or a cosine function. And there's typically three things that they can change. They'll change A, the number in the front. They could change B, the number multiplying inside of the parentheses with the X. Or they could change K, and K will always be like a number adding, typically at the end. Some things to kind of remember: that sine graphs typically start in the middle, and cosine graphs typically start at the maximum or minimum. So if you remember, kind of sine graphs kind of start in the middle, will go up and then down and kind of end back at the middle. Again, if you remember, for our cosine graphs, we're normally starting at our maximum, we'll go down, and then we'll kind of end back when we get to our maximum. So uh,
The only thing I'm really gonna miss is
so again, the amplitude is A. That's going to be kind of the height of your graph. It's kind of the distance to go to the maximum or the minimum. K, the number we're adding at the end, is kind of the middle line. Again, it kind of talks about how much it goes up or down. So B is a little confusing because B is going to change our period. And they'll normally use this equation: B is equal to 2 pi divided by P. Sometimes when they talk about the period, because period and B are kind of related, the period is how long it takes to do one full cycle. So in order to find P, we do 2 pi divided by B. So that's kind of what B tells us. So, and then sometimes they might talk about the frequency, how often it's happening. They'll tell you the number of cycles that are happening. Again, normally we can use our period. Our period is equal to 1 divided by the frequency, or the frequency is equal to 1 divided by the period. So depending on what they're asking for, you might need to find the frequency too. So, looking at this first example, says a clock is located on a wall. The center of the clock is located 56 feet above the ground, and the minute hand of the clock is 2 feet long. The function h is given the height of the top of the minute hand above ground level in feet at any time after noon. I'm going to draw a picture. Here's the ground. Here's my clock. So again, it said the center of the clock is located 56 feet above the ground. So this is 56 feet. Again, the minute hand is 2 feet long. So just this little amount is 2 feet. And when it's 12 o'clock noon, where are the hands pointing? The hands, I don't know if you guys know how to tell time, but so I can tell when the hands at the top, this would be at 58 feet. When it's at the bottom here, this would be 54 feet. She is. So a couple things I can tell, my amplitude is going to be the 2 feet. The middle is going to be the 56. I want to use cosine since it's starting at the maximum. Again, I want to think kind of where is it starting? Is it starting kind of in the middle or is it starting at the maximum? It's starting at noon, which is going to be when it's pointing at the top. And our period is 1 hour, which is 60 minutes. So normally to find b, I need to do 2 pi divided by p. So again, the 56 would be my middle. That's how much it's kind of going up. My amplitude is the 2. That's the minute hand. And because of my period of this being an hour, I found out my b is pi over 30. So again, because this is a cosine function, I want to use this guy. These are parentheses. So again, I'm plugging in A, B, and K. We get on the front, we go to the back. Going once, going twice. Go to the back. So for this one, it says the tide has a maximum of 8 meters at 2 a.m. when time is equal to 0. So again, this is when I'm starting. And then a minimum depth, so my minimum is going to be 2 meters at 8 o'clock. So my maximum goes up to 8. My minimum goes down to 2. If you want to find this middle line, I want to find kind of like the average. I can do 8 plus 2 divided by 2. So I end up the middle is going to be about 5. So again, they told me it's going to start at 8 at 0, and it's going to go down to the minimum of 2 at time of 6. If I want to kind of finish my graph, normally cosine, I know this is a cosine graph. It's starting at the maximum. To find the midline, again, I already kind of found the middle by finding the average. So K is going to be 5. My amplitude is how much you have to go up by to go to the maximum. To go from kind of 5 up to 8, I have to add by 3. And I have to think, how much do I have to go down by to go from 5 down to 2? I'd have to go down by 3, so the amplitude A is 3. Going up by 3 and down by 3. And again, to find your period B, I have to do 2 pi divided by P, where P is my period. Period is how long it takes to go kind of from start to end. Now, if this took 6 seconds to go all the way to the end, this would take 12 seconds. It would have to double since it took 6 seconds to get to the minimum. So to get back to the maximum, take another 6 seconds. So the period would be 12. So to find B, I have to do 2 pi divided by 12. So B would be pi over 6. They told me that time up here was t is 6. Yeah. If I know it took 6 hours to get to the minimum, it would take 6 more hours to get to the maximum again. So the whole period would be 12. Kind of go from maximum back to the maximum for it to do one full cycle. So for my equation, I'm going to do A cosine of B x plus k. And technically, we can make this a t. They want to find out when time is 6. So if I plug in a 6, you'll actually see that the 6 will cancel with the 6 on the bottom. I get 3 cosine of pi plus 5. You can look at your unit circle, make sure you are in radians, because this is radians. If I do the cosine of pi, or you can look at your unit circle, you get negative 1. So I get negative 3 plus 5 gets me 2, which means it's low tide. It's going to be 2 meters deep at 2 o'clock. Let's look at 2 more. This one just gives us a model, and it's just going to ask us to find the equation. So you're going to have to be able to kind of read it and think about what they're telling you. So the population of bears is going to oscillate 42 above and 42 below the average of 221 during the year, hitting an average of in January when t is 0. So again, my average, the middle amount is 221, and it's going to go up by 42. So if I add 42, 221 plus 42 gets me 263. 221, what is it, plus 42? Again, my max is that. If I minus 42, goes down to 179. Now again, this said it starts on the average, and it's going to go up and go down. Again, my K, the middle is the average, is 221. The amplitude is how much it's going up or down by. It's going up or down by 42. So that would be my A. And again, to find my P, I have to do 2 pi divided by B. There's 12 months in a year, so it's going to happen throughout 1 year, but this is in months, so we have to be careful. So this would become pi over 6. Oops, this is B, sorry. So since this is starting in the middle, this would be a sine graph. So my equation, I guess I want to call this P, population of P. is going to be A sine of B t plus 221. Last example. A Ferris wheel is 40 meters in diameter and boarding the platform that is 24 meters off of the ground. The 3 o'clock position on the Ferris wheel is level with the loading platform. The wheel completes one full rotation every 8 minutes. Write an equation for h of t that models the height of the Ferris wheel. So again, I want to think about a couple of things. I want to think about kind of the middle and how high does it go and how low does it go. So it starts in the middle. This is where I'm starting. And again, it's 24 meters off of the ground. So that's the middle. This is 24. It says the diameter is 40 meters, so going all the way across is 40, which means my radius is 20, 20 and 20. So if I think about it, you're starting here on the wheel. You're going to start rotating as you kind of go around. You're going to go up to the top of the wheel. When you get to the top of the wheel, this is 20 plus the 24 from the center. So that would be when you're up at 44. That would be when you're up at the top. This would be your maximum. You're going up by 20. Then you're going to come back. You're going to keep going as you're spinning. You're going to come back down to the center. Then it's going to keep rotating around. It's going to go kind of down below by 20. Down to the ground, it's going to go to 4 above the ground when you get to the bottom. You minus 20. And then it's going to kind of keep going, and then you're going to end up back at the loading platform where you started. So there's my graph. So again, my middle is 24. The amplitude, how much it kind of goes up and down by, is 20. The radius, you have to be careful because they gave us the diameter for this one. And again, for b, I have to do 2 pi divided by p. Now, my period is how long it takes to do one full revolution. So my p would be 8 in this case. So b would become pi over 4. I'm starting in the middle, so this is a sine graph if it's starting in the middle. So for my equation, they wanted me to write as h of t. So h of t is going to equal to a sine of b x plus k. So again, however much this goes up or down by, that's my a. That's the number you want to pull in front. Whatever my middle line is, wherever that is, that's my number at the end. Whatever my b is, I'm putting that in here. That's it. Last new thing. And to be fair, I think this is just a bonus question on your test on Thursday. So
He tagged his friend. Don't.
So, for your homework tonight, there's a couple word problems for you to look. I think there's four. Oh, there's more than that. There's six. So the first couple, one and two, are a little bit more involved, kind of like the first two we did, and then on the back, they just kind of give you a description, kind of like the last two we did. These top two, four and three. Oh, it should be three and four. I numbered those backwards. Sorry. And then five and six are kind of like the Ferris wheel one I did at the end. So last homework assignment for the year, kind of crazy.